Alright, hey guys, today we're going to be learning about proportional and non-proportional relationships. So, if you can read, it says two related quantities are proportional if they have a constant ratio between them. If two related quantities do not have a constant ratio, then they are non-proportional. Okay, so let's look at example 1. It says the cost of a 1 CD at a record store is $12. Create a table to show the total cost for different numbers of CDs. Is the total cost proportional to the number of CDs purchased? So we've already made a table right here. I've got number of CDs and I've got my total cost. So if we were looking at graphing this, this first column would be my X, the second would be my Y, which we're going to get into that next week. So what I want to do is I want to make a ratio. I'm looking at the total cost, or it's asking is the total cost proportional to the number of CDs purchased. So that means my total cost is going to come on top. It's going to be my numerator. My number of CDs is going to be the denominator, so the bottom of the fraction. So right here, when I make my ratios, again, like I just said, total cost on top, number of CDs on bottom. So I'm just looking at that first column. So the total cost is $12, so that's going in my numerator. The number of CD is 1. And then for my 2 CDs, 2 is going on bottom, 24 on top. 3 CDs is $36, so I've got 36 over 3. And then 4 CDs is $48, so I've got 48 over 4. If I simplify all of those ratios, so 12 over 1 simplified is 12. 24 over 2, 24 divided by 2, that is 12. 36 divided by 3 is also 12, just as 48 divided by 4 is also 12. So these are all equal fractions, meaning that each CD is $12. So this would be a proportional relationship because every single ratio is equal to 12. They are the same ratios. Okay, so this is a proportional relationship. Example 2, I am talking about bowling. So it says the cost to rent a bowling alley is $9 per hour, plus $4 for shoeing them. Create a table to show the total cost for each hour a bowling lane is rented. If one person rents shoes, is the total cost proportional to the number of hours rented? So again, it's asking, is the total cost proportional to the number of hours? So cost is going to go on top, number of hours is going to go on bottom. So whatever it's asking what is proportional, basically the first thing that's going to be listed in your sentence is always going to be your numerator. The second thing is always going to be your denominator. So I've got my table here. I've got my number of hours, my total cost. So 1 hour at the bowling alley is $13. I got that because it was $9 per hour plus an additional 4 hours for shoes. So 9 plus 4 tells me that it's going to be $13 to bowl for just 1 hour. I have already paid.
That think that I didn't call third round, I just got the call. Third round may be dismissed. Third round may be dismissed.
So I've already paid my $4 for my shoes. So I'm just paying an extra $9. So for 2 hours, it's going to cost $22. From there, again, if I'm going to extend it and play 3 hours, I only have to pay $9 extra instead of the total $13 because I don't have to pay for my shoes again. So 3 hours to bowl is going to be $31. 4 hours to bowl is going to be $40. So if I look at all of those as a ratio with my cost over hours, that means I've got 13 over 1, which is the same as saying 13. Then I would have 22 over 2, which is 11. 31 over 3, which is 10.34. And then 40 over 4, which is 10. Are all 4 of these numbers the same? No, they are not the same, which means this is a non-proportional relationship. So if all of your ratios do not simplify to give you the same number or the same ratio, that means it is not proportional. Okay? So let's look at do an example that is not already given to us. A photo developer charges 25 cents per photo. Is the total cost proportional to the number of photos developed? So first off, I'm going to need to make my table. So I'm going to have my number of photos on top. And then I'm going to have my total cost on bottom. Not a very straight line. Okay, so first I want to see how much it's going to cost for just one photo, 2 photos, 3 photos, and we'll go all the way out to 4 photos. Okay. So I know that one photo, they already told me it's 25 cents. So again, this total cost, that's going to be in money. Okay. So one photo is 25 cents. So if one photo is 25 cents, how much is 2 photos? You're adding 25 cents to it, so that would be 50 cents. 3 photos, 25 cents plus 50, that would be 75 cents. And then 4 photos would be $1. So now that I have my table drawn, I want to make sure, I want to compare my ratios and see if they're the same, meaning that they would be proportional, or if they're not the same, they would be non-proportional. So remember, I'm comparing cost to photos. So that means my ratios, I'm going to have cost on top, and then the number of photos on bottom. So if I look at the number of, or the cost for one photo, that would be 25 cents over 1. 2 photos would be 50 cents over 2. 3 photos, that would be 75 cents over 3. And then 4 photos would be $1 over 4. So now I want to go through and make sure or see if they are the same or not. So 25 cents, that is just like saying 25 cents, or 25 cents over 1, that's the same saying 25 cents. What is 50 cents divided by 2? That's 25 cents as well. So I know that those two are equal. 75 cents divided by 3, that's also 0.25. And then $1 divided by 4 would also be 25 cents. So all 4 of these ratios are the same. So that means that this relationship is proportional. Okay. So our ratios are the same, meaning that they are proportional. So they are all equal to 25 cents. All right, example number 2. It says a soccer club has 15 players for every team, with the exception of 2 teams that have 16 players each. Is the number of players proportional to the number of teams? So let's go ahead and make our chart. So I'm going to have teams on top of my chart, and then I'm going to have my players on bottom. So again, we're just going to go 1, 2, 3, and 4. So team 1, 2, 1 team, 2 teams, 3 teams, 4 teams. One team, we're talking about with one team, it tells me that we've got 16 players, okay? How do I figure out what team 2, or how many players team 2 has? You started out with 16, so here I went from 1 to 2, so I added 1, so I'm going to add 16 again. So 16 plus 16 gives me 32. If I add 16 again, that tells me the players for 3, which would be 47. And then adding 16 again to 47 gives me 62. So now that I've got my chart, I want to make them into ratios. So I'm going to have players on top, teams on bottom. So for one team, I've got 16 players. 2 teams, I've got 32. 3 teams, I've got 47. And 4 teams, I've got 62 players. So let's go through and simplify each fraction or each ratio and see if they are the same or not. So 16 over 1 is the same as saying 16. 32 over 2, that is also 16. So 16 equals 16, yes. So I know that those two are the same. What about 47 over 3? So 47 divided by 3. That actually gives me a decimal, just 15.67. So that is clearly not equal to 16. If it was rounded, yes it would, but we're not rounding. So 15.67 is not the same as 16. So they are not equal to each other. So could we already go ahead and say if this is proportional or not? Yes, we could go ahead and conclude that this is not proportional, but we want to go ahead and see about this other ratio, just for fun. So 62 divided by 4, that is 15.5. So again, those are not equal. So because all of the ratios are not equal, 16, our first two ratios were equal, but every single one of them has to be equal in order for it to be proportional. So because all 4 of them are not equal, this is a non-proportional relationship. Whoops. Okay. So again, if your ratios all come out to be the same, you're proportional. The relationship is proportional. If they are not the same, it is non-proportional. Okay, so your homework is going to be out of your book today. It is written over here on the sideboard. It's going to be page 274, numbers 5 through 13 odds, and then numbers 17 through 19. So 17 through 19, you're doing 17, 18, and 19. But 15 through 13, you are just doing the odd numbers.